So it says a rectangle is cut from a circular disc of radius 6 centimeters. Find the area of the largest rectangle that can be produced. So what that's saying is, right, you've got a circular disc like this, right, and the radius is 6 centimeters. Got it? Yeah. And we've got to cut the largest possible rectangle from that. Got it?
Yeah.
Okay, now, what would that length be?
6.
Yep. And let's have a look. That length would also be 6. Yep. That length would be?
6.
No, it won't be 6. And that length will also be something that's unknown, right? Cool. Got it?
But it's all from the same radius. Oh wait, no. Okay, yeah.
Got it?
Yeah.
So because the circle's kind of going to go like this, right? Yep. So what we've got to find is the length, and we've got to find the width of this rectangle. Does that make sense?
Yeah.
Okay. Now these questions get pretty tricky, all right? But this is what we've got to do. We've got to find a value for the width and a value for the length. So this is y, and this is x. Got it? Yep. All right. So what's the relationship between x and y and 6?
Same?
No.
Oh, wait. So x squared
Yes.
is equal to 36 minus y squared.
Okay. X squared plus y squared
Equals
is 36. Good. Okay. Now that's going to be key, right? That's going to be integral, right? Integral. That's going to be really important. Okay. Now, what is the area of this rectangle?
X, y over 2.
Sorry?
X, y over 2.
No, not quite. What's the length of this rectangle? 2y. Does that make sense? If that's y, then the area is going to be 2y, yeah? And what's the width of this rectangle?
2x.
2x, good. So what's the area of this rectangle?
4xy.
4xy, good. Got it?
Yep.
Now, in order to differentiate this, we need to go from 1 to 3 variables down to 2 variables. Got it?
Okay.
We need to go from 3 variables down to 2 variables, right? One being the independent variable, the other one being the dependent variable.
Yeah.
Got it? All right, now let's have a look at this. X, Y. Okay. We're going to have to get rid of one of them. Doesn't matter which one. Okay. Let's get rid of Y, right? So let's make Y the subject of the formula here. You got Y squared is equal to 36 minus X squared. Got it? So Y is going to be equal to the square root of 36 minus X squared. Now, why is it going to be positive and not negative? Well, because we're dealing with a length. So it can't be the negative value. Does that make sense?
Yeah.
Yep. So what is the area now in terms of one variable, not 2 variables? For x,
36 root 36 minus x squared.
yes. So what we're going to do is going to 36 minus x squared all to the power of a half. Good. And the reason why we put it in this form rather than this form is that it's going to be easier to differentiate. Got it?
Yeah.
Now, how do we find the largest area of the rectangle?
Maximum value.
Yes, maximum. When do we have a maximum?
When y dash is
Yep.
less than 0.
No, when y dash is
Greater than 0.
equal to 0.
Oh, okay. If y dash is equal to 0 and y double dash is less than 0.
Yes. So we want so in this case it's not y, it's going to be a, right? Yep. So it's when a dash is equal to 0 and a double dash is less than 0.
Less than 0.
Got it? So let's work that out. Okay. So we got woo. Let's do a rub that out. So we want when a dash equals 2. Now got to use the product rule here, right? So u equals to 4x, v equals to 36 minus x squared to the power of a half, u dash equals to 4, v dash equals to a half times minus 2x, yep, times all of that to the power of, so 36 minus x squared all to the power of minus a half. Does that make sense?
Yep.
Yep. Now that half there cancels with that there, leaving us with v dash equals 2, what is it? Minus x over square root of 36 minus x squared. Got it? All right. So what we should get, u dash v minus uv dash, u dash v plus uv dash equals to, let's have a look, 4v times 36 minus x squared to the power of a half minus 4x squared over 36 minus x squared to the power of a half. Got it?
Yeah.
Which, when we put everything over 36 minus x squared to the power of a half, is going to be equal to 4 times 36 minus x squared minus 4x squared.
Okay.
Does that make sense?
Yep.
Yep. Now, all of that, the top bit, is going to simplify to, what's 4 times 36? 144. Minus 4x, minus another 4x, minus 8x squared, all on 36 minus x squared, all to the power of a half. Got it? Now, all of that is going to be equal to 0, right? Because we want when a dash is equal to 0. Yep. So let's do that. So it's going to be 144 minus 8x squared equals to 0. 8x squared equals to 144. Let's have a look. 8 divided x squared is equal to 18. X is equal to plus minus root 18. Okay. Now, it can't be negative, right? So we're dealing with root 18. Got it? So that's what's going to give us the maximum area, but we don't know whether it's a maximum or minimum yet. We just know that it's a turning point or a stationary point. Got it?
Yeah.
So now what we've got to do is basically, we can either find the second derivative, or what we can do is test points on either side of the first derivative. Got it? Yep. So if we test points on either side, so we go x equals to So we've either got x is equal to root 18, greater than root 18, or less than root 18. A dash would be equal to 0 here. Yep. If it's less than root 18, right, then all of this is going to be less than 144, which means that it's going to be positive. The bottom is also going to be positive. It's going to be positive anyway. The bottom can't be anything but positive. So if x is less than root 18, it's going to be positive here. And if x is greater than root 18, that's going to be bigger than 144. So overall, the numerator is going to be negative, right? And so you've got the graph slope looking like this: positive, 0, negative, which kind of looks like that.
Yeah.
Which is a maximum. Got it? So root 18 is one of the lengths, right? The other length will also be, so the other length, we basically put it into this formula, work it out. Yep. And we should get an answer that should be, do you want to work it out? I reckon the answer is 72. That's my guess.
Okay.
Just put it in your calculator. Yeah, 72.
Okay.
Does that make sense? Yeah, these questions can be kind of tough. But the key is, right, oftentimes when doing maximum minimum questions, what you need to bear in mind is that there's going to be two formula that you work with. Yep. And then you've got to substitute out one of the variables. You'll often have 3 variables. You've got to substitute one of the variables out so that you end up with 2 variables. Got it?
Okay. Yeah.
Yeah. That's really the key for doing some of these maximum minimum questions. Is that where you're getting stuck? Finding the formula that you need to
Yeah, and often I can't draw it either.
Oh, okay. Yeah, yeah.
I can't visualize it.
Yeah, yeah.
I suck at that.
Yeah, yeah.